Welcome to our AP Pre-Calculus video for 1.6 Polynomial Functions and Behavior. I am Coach Meidenbauer. Make sure you like and subscribe. Let's get rocking and rolling here. So this lesson here should be almost entirely review if you've been going through the videos here, because we've covered a lot of the stuff already. The only thing that's going to be new is us actually going and writing our limit notation. And I have showed you how to write limit notation stuff on 1.5 day 1. So here we go. So we're going to talk about end behavior with polynomials, and we just got to be aware of the verbiage. So the first bullet point there is the input value increases without bound. The output values will either increase or decrease. So please understand, if something says the input values increase without bound, that means we're doing a limit that approaches infinity. So the biggest difference we're going to get here between these two things, I'm going to highlight it for you. If we increase without bound, we're going to have those positive infinities. Okay. If we, second bullet point now, decrease without bound, you're going to see those negative infinities. That's really the new information here. Let's go ahead and snag these down here. And that talks about even degree polynomials and behavior being the same. We have already tackled that. Again, go to my previous videos, and when you do, don't forget to like them, subscribe, all that fun stuff. So here we go. First example here, identify leading term and degree of the polynomial, and then we're going to write the appropriate limit to describe the end behaviors. So here we go. So leading term here, this is going to be a degree 3 because the highest degree is a 3 of all the terms. These are not linear factors. If these are linear factors, then we would add all the degrees of the linear factors up. It's not standard form. We just look at the highest number, which means that my a value is going to be -2, which, by the way, is negative. It's important to know. So this is odd negative. I can't even write correctly. Odd. Oh my gosh. Odd negative. So which means if I'm looking at my end behavior, odd negative looks like this. I don't know what's going on in between. I don't really care. Odd negative looks like that. Okay. Again, previous video. Go check it out. So let's go ahead and write the appropriate limits. So I'll do the left one first. So again, when we write limits, I always usually a cursive L as x approaches negative infinity of p of x. Don't rewrite the whole thing over. Come on, that's not cool. So what's my left end behavior? I drew it right up there. It's going to be positive infinity. That is my left end behavior. My right end behavior is going to look like this. My right end behavior is going to be negative, so it's going to be negative infinity. That's it. That's all it's asking for. Okay. Next examples here. We're going to write the, it says to write the possible degree for each polynomial. I'll get to why that says possible in a second. What is the sign of the coefficient leading term? Do that as well. And then we're going to write the appropriate limits to describe the end behaviors. Okay, now why does it say possible degree? If we're just given just the graph, we can't find the actual degree. Reason being is, like, we have a couple roots there for this first example. It looks like it's at -1, 2, and almost 5. Like maybe it's a 4.7. We don't necessarily know if those are cuts. You can look at it and be like, they look like cuts. I'm going to argue, yeah, those look like cuts. But maybe there's a little bit of a flatten in there. We don't necessarily know because we're not given the exact properties of this graph other than just looking at it. We also don't know if there's any imaginary roots in there. Imaginary roots don't show up at all on a graph. So could this first graph right here be a degree 30? Sure could. We just don't really know. Actually, it can't be a degree 30. A degree 29. We don't know, because clearly those are all odd. And then if there's imaginary, they're all even. Anyway, so let's look at the lowest possible degree. So this has 3 roots. So this is 3 roots. I'm going to say that those are odd roots. Okay. So because we have 3 odd roots, our possible degree is degree 3. That's our possible. I'm not telling you it's degree 3. I'm telling you that it's possible. Okay. What's the sign of the leading coefficient? The sign is going to be the end behavior. So write end behavior is going to be our sign. That means A is positive. Okay, so it's always our right end behavior. So let's look at our limits here. Let's look at our left limit. I'll put an L for left. How's that sound? This limit as x goes to negative infinity of, did this label this function for us? Oh, it did not. Let's just call this, it says it's, let's call this g of x, because the one below it is f of x. Let's just call this g of x. I'm sorry that it's not labeled. Whoever made these notes, what the heck? I mean, g of x is going to be negative infinity. Okay, because we're down. It's our left end behavior. Right end behavior is positive infinity. Okay. Not bad. With that being said, go ahead and give this one below it a try here for f of x and see how we do. Hit pause. I'll see you in a second. And we're back. So let's go ahead and go through everything that we just did before. Possible roots. I'm going to count 1, 2, 3, 4. They're all cuts. Looks like cuts. So we have a possible degree. Four. Our right end behavior is negative. So our left end behavior is below negative infinity. Our right end behavior is also below its even function, is negative infinity. Okay. That's it. Wraps it up. Short video here. Don't forget, like, subscribe.